Thank you. Good evening, everyone, or pre-afternoon. How's everyone doing after the party yesterday? People awake? Kind of? Yay, good. My name, as she said, is Aslak Knutsen. I'm the technical project lead of the Arquillian project. I'm a senior software engineer at Red Hat. And today we're going to be talking about one of the extensions that are in the Arquillian universe and how to test microservices or Docker-based things with it. Well, that's me, obviously. Anyway, containers. What we're going to talk about essentially is Docker, and Docker is a container or a way to containerize applications in isolated environments based on the Linux kernel and so on. You get your own process space, and it's fairly easy to build these. There's a little Docker file that specifies how you're going to build up this image. And you have other tools like Docker Compose, which allows you to do more than one file. We're going to look at a little example. Might be a little bit hard to see. But essentially what's going on here is we're saying that we're going to inherit from some base image. We're going to make a directory. We're going to change the working directory to this new directory. And we're going to copy a file from our local location into that new image. We're going to expose a port, and then we're going to make a web service, and the smallest microservice I guess you can have. It's essentially serving one image in a bash loop. So, let's see. There we go. So if we run this little script, you can see this this bash script is essentially just running the same commands that I'm showing at the bottom there. We want to build it. We're going to give that build a name, which is the JDD web server. And then we're going to run that and expose it on port 8081. And that's going to serve the content of this fantastic little microservice of ours. So let's run it. Of course, have a Docker. You can see we have a Docker local process that is up and running. And let's run it. So it's building the image. Let me see if you need to up this a little bit. And there it started and running. Oops. So now we can communicate through HTTP, of course. This one 001. I have no idea where that is. There we go. 001 8081. That's our microservice for you. So that's Docker in a nutshell, essentially. So we can now look and see that we have a Docker process or a Docker container that's running. We can kill it. Oops. And we can remove the image again as well, or remove the container. What was there? D8. There. And we cleaned up. Now there's nothing running. So, back to the presentation. Oh, that was a demo. Sorry. So, introduction to Arquillian. Not too many of you who knew what Arquillian was. So, I'm going to go through it a little bit, what the basics of it is. So, Arquillian is not a testing framework per se. It's a testing platform, we call it. We say that because it's not a replacement for JUnit. It's not trying to compete with any of the what you normally would consider to be a test framework. It rather integrates with them and allow them to control the different life cycles within Arquillian. So Arquillian can be run with JUnit, TestNG, Spock, Cucumber, and a bunch of the different test runners. And we just integrate and allow things that are happening in the test framework to populate into Arquillian, and then Arquillian does its magic. So from one perspective of Arquillian, you're going to start up with needing to select some kind of environment that this thing is going to run in. Arquillian layers itself as some form of integration testing framework, so integration up. You can still use it if you want it more on a unit level, but still that's where it's probably most practical. So the first step is select some form of container. Container in Arquillian is very loosely matched to be some form of runtime. It could be a Java EE application server. It could be just a remote or just a different JVM. It could be a Spring Bean container, a Vault container, any form of environment that is going to run your code. And it doesn't really matter if that's on your local machine, on a remote machine, in a different process, in the cloud, or wherever that container might be. So then the next step for Arquillian internally, after you've selected it, is to either start this container or connect to it, depending on what kind of mode it's in. Then it goes into a packaging process, which is essentially where you're defining the environment for where this test case is going to run. So you can add all dependencies, add classes, add files, add configurations, and all of that, and kind of make a package and deliver that to the configured container. And the container will then, of course, run that piece. I'll show you some examples of the APIs to how to add the different resources later. And then the fourth step is potentially to run these tests inside the container. So while the test case itself is running on the client side, potentially in your IDE or in maybe in Surefire or that kind of thing, the actual test methods are kind of forwarded to a different runtime, which could be executed on a different server. And when you're in that environment, which is hopefully more real or closer to what you're going to run in production, you then have access to all the resources that container might provide. Like you can inject live EGBs, CDI, data sources, JMS connections, and anything, security managers, etc. And that's all the live ones. It's not a mocked version of something. It's the thing that your application would actually run with. And then, of course, it captures the results and returns those results back through the test framework's path, essentially. So as far as JUnit sees it, and as far as Maven Surefire, etc., sees it, there's no change for it that this test result happened to come from a different server somewhere. Maven Surefire will work exactly the same. You will still get the green bars in the IDE and all that. And then, of course, there's a cleanup phase. So how do we write this stuff? So this is an example of an in-container test with using the JUnit integration. So the first step is to kind of tell, using the JUnit run with annotation, to hand over the control to Arquillian. And at this point, Arquillian can kind of do whatever it wants. One of the first things it does is to read the new deployment annotated method. That's where you find the environment and the scope of this test. This is where you add your classes, your configurations through this Fluent API called shrink-wrap. There's shrink-wrap and shrink-wrap resolver, which does dependency resolution, and there's shrink-wrap descriptors, which does content of XML files, for instance, or JSON files, etc. In a similar Fluent way. And then when you come down to step 3 here and the inject, currently this is some form of a CDI bean, so we can inject it using the CDI annotation. And at this point, we're actually inside the target environment. And the thing we inject is the real thing that is being deployed. Again, this is not a mock of any form. Inject is not per se the only thing we support. In this case, when you do an inject, we're kind of handing it over to the CDI container to get that to inject into us. But there's at EGB, at resource, at AutoWire, and all of the different frameworks as injection points. And then it's the standard JUnit test method that is now executing somewhere else in the world and can return the result as normal, essentially just asserting some state on that live bean that we put in. That is when you moved all the execution into the environment, the white box type of testing. Then you could do more of a black box as well, which is if you wanted to test REST endpoints, HTML pages, and that kind of thing, you don't want to be inside the server necessarily. You want to be on the outside to kind of throw things at the server. And then the first step is to define the deployment as testable false, which essentially means don't do anything to this deployment. This is deploy the deployment as is and run the test case wherever that is running already. So it will be running inside your IDE, will be running inside Surefire. But we can, since we are in control over the container and control over the deployment, we can inject back useful information like the URL to where this thing is deployed. So you don't have to have a separate property file, for instance, for Selenium to say that, okay, now we're running against the staging server, and that's that in that IP and some kind of subpath and so on. You can just let Arquillian handle that since it already knows all the information and can inject it into you. And then in this scenario, we're just using rest assured to do a REST call to a REST service, which is simple enough. So this is the world first. Over the years, we've gotten so many complaints about how difficult it is to set up Arquillian. And we've finally done something about it, hopefully. You guys are the first one to see it demonstrated live. So it's a JDD exclusive. It was released on Friday, the Arquillian universe bombs, which is essentially any extension that exists out there exposed through one bomb file in a unified naming and versioning and so on. So the user shouldn't have to know the details of how to set up all the individual dependencies of the different extensions, because they vary somewhat depending on who wrote it. So this is the unified view. You add dependency management to the Arquillian universe POM file, which is a BOM file, and then you just add dependency to the individual modules. They're all named or Arquillian universe, Arquillian dash something. So JUnit, TestNG, Spock, persistence, drone, graphene, Jakuku, and so on and so on and so on. The best way so far is to use Spring's BOM plugin. They have a plugin that can understand BOM files, essentially. And then you just do the same thing. And yeah, so to add a container of a choice, in this case, we're using the Arquillian Chameleon container, which is not really a container, it's a proxy container. It's a simplified view of a container again. So it can run any other container. So let's just see how that runs from pure Arquillian. Let's see. The demo. So we have our little application here. We're going to convert the units and so on and so on. It's the same you saw on the slide, so I'm not going to go through this time. But we have our run with, we have our deployment. And since this is integrated with JUnit, all you have to do is essentially do run as JUnit. And in this case, it's set up to run against a managed container, so we'll start up the server as part of the test case. We got a green bar. So that was the in container example, and this is the remote example. Okay, set a breakpoint here just for fun of it. Run it again. Oops. Been debugging some other stuff, obviously. Where were we? And yeah, we're stopping at our breakpoint. I'm not sure if you see any of this, but we're running within the Eclipse runner at this point. Should be, oops. Yeah, the remote test runner on the clip, so we're actually executing on the client side. And invoke it. Oops, invoke it. And we should have another green bar. So that is the case where we're actually, let's look at the configuration here just to show it. We're using the Chameleon container to run against a Wildfly 9 container. It could be inconvenient, of course, during development to have to start and stop that container all the time. So you can easily just change that to remote and have your container started standalone on the side. You start it up in the morning, and then you just run your test cases as you would normally do. You can see it then deploys to it, and what did I do? Oh, right. I didn't start it with the port forwarding stuff. So let's remove that. There we go. And you see deploy. So the test is running inside the container, in the weld container, in the EE container, etc. So that's Arquillian in a few minutes. So the point of Arquillian is, as you could see in the test case itself, there was nothing there kind of tying this specific test case to a Wildfly server or to a Liberty server or anything. It was only describing specifically which environment it needed to run under, and Arquillian in the background can kind of provide the environment that you want. So it's easy to swap between testing different versions of an app server or different types of an app server and so on, depending on what you need to test your application under. And it's meant to execute in whatever environment that you're already executing in. So that being JUnit or Surefire or Jenkins, etc. It doesn't really matter. And yeah, it's a testing platform. We're not trying to reinvent the wheel everywhere. So we integrate with a lot of other projects to coherently put them into one umbrella and trying to get them to work in one engine instead of there being one framework that does one part and some other project that does some database stuff. Arquillian tries to tie that together and kind of allow you to run the database stuff in a container that actually has the database, and same with the Selenium part, for instance, actually deploy something so you can run the Selenium tests against and have that whole life cycle. So, to the topic of today, Arquillian Cube. That is the Arquillian manager for Docker containers, or anything Docker per se. It's not necessarily tied to the Docker runtime, if you want to call it that, but it's anything to do with organizing the Docker files and building them and so on. We'll see. Might as well run against Docker machine as the Docker daemon or OpenShift, etc., etc. That's just a configuration. And based on that, you can allow Cube to start up then the containers that contain servers of some sort, and then use the remote adapters to connect to those servers. Of course, it's not just bound to one container at a time. You can orchestrate the whole thing and so on. And there's also not necessarily for an app server. There's any type of thing that can export or that you would have network access to, essentially. Some examples are Dropwizard, Spring Boot, Node, Netty, Vertex, whatever. And interestingly enough, that little cube there is a fridge. I want one of those. Those are cool. So let's try our first cube test. So this is just going to be a very straight up JPA running on a Wildfly server that is Dockerized. The deployment is happening to the server as it's a Docker image, so it's not pure Docker per se, but the app server is a Docker image, exposes the management APIs, and then deploys into it. So that's kind of the first step of some form of Docker. So the test looks similar to any of the other ones we've seen so far. There's nothing here specifically to the containers. There's nothing here specifically to Docker or Kube. It's just an environmental definition, which is the deployment. And then you inject the resources that you want, and you do something with them. There's a new annotation down there that's called using dataset, which is from the Arquillian persistence extension. Allows you to give it some YAML or JSON or XML. Uses dbunit under the hood and imports that into the database before the test runs. So the kind of the database is set up, and you don't have to deal with that code as part of the test method. It's just the logic of comparing. And as far as, or continuing down the path of the universe BOM, to get Kube Docker support, you add org Arquillian universe, colon Arquillian Kube Docker. That's it. Then you have Docker. And persistence, of course. It's the same, Arquillian persistence. And again, we're going to use Chameleon in this example. So now we're going to go into a part that you haven't seen before, I guess. This is the configuration of the container setup in Kube. Kube Docker by itself runs against, as I said, the Docker daemon, which is kind of the default mode, and Docker machine. And as long as those things are local, if you're not using Docker machine, if it's just the Docker daemon, then you can remove the machine name, of course, and it will assume, based on operating system and so on, what the URL of the Docker daemon is going to be. For instance, if you're on Mac or Windows, it will know to call the boot to Docker executable to find the IP of the server, and etc., etc. So that's essentially on a Linux box and a Mac or Windows. As long as you're using the Docker daemon, the only configuration you need is the definition of the container itself, nothing about the daemon. If you're running it with Docker machine, you need some form of machine name to tell you where it's going to find. But again, it knows how to communicate with the Docker machine to find the IP address of that machine. So next here, we're just defining inside the Docker containers. There's a little YAML type of description. There's some name, and we're going to build this image. We're going to build it based on the Docker configuration, or the Docker file that's in that location. We're not going to cache it. We're not going to cache it, and we're going to remove it when we're done with it. And we're going to have a specific port binding. We're going to remap the ports from 8080 to 8081 and remap 9090 to 9091. And then comes the Kube container integration, which essentially says that if there's a Docker container with the same name as the container qualifier, which in this case is both is Wildfly, it will assume that that is the container that you're going to run. It will then bind that container to the same lifecycle as the container. As the Docker container gets the same lifecycle as the container. So when the container starts up, the Docker one will start up first, of course. So then it has all the IP addresses and port numbers, etc., for that host, so it can configure the remote adapter for you. That's why you don't see any host or port configuration on this remote adapter. So let's try to run that as well. Just see how it runs. So at this point, I have shut that one down. Wow, we have a machine here. Oops. You see that? Yeah. We have a Docker machine that's called dev that's up and running. We can log into that one. And there's no images, or there's no containers running at the moment. So let's go to the next example and run that. In this case, we are going to run it against, it's just a Wildfly server with a local database. And So the test case looks like this. If you see that, so we got the deployment, the environment of what we actually want to deploy, using a couple of data sets that are being inserted before we go, and then we go through and test them. That's not per se the interesting part. The interesting part is now. Let's see, where did the other window go? Oh, okay, never mind. So this is again then just run as JUnit. And we should now see should we not? Happening? It is running. Okay, demo gods. Docker tab. Oh, it's probably building it then. What are you doing? Okay, well, let's drop that one then. I don't know why that stopped running all of a sudden. Anyway, of the orchestration. So we all know the view of how we want our orchestrated services and processes and environments to be, but in reality, we all know it's a bit more like that. We're banging around on the drum. Hopefully something runs or not. In this case, it didn't. Well, so the orchestrated part of a kube is where you want to have several several Docker containers that are operated or that has a dependency chain between them. So the simple example that we're going to show is some form of server that has a dependency on a database. And then Kube will then automatically potentially start that server for you. If there's a dependency, or if that has a dependency, it will start that server, and so on and so on. So kind of can build up the whole system for you, essentially, and allow you to move from kind of an application integration test to a complete system test, if you wanted to, with pulling up FTP servers, mail servers, databases, and Cassandras and whatnot. So the configuration is very similar, or it's essentially exactly the same, just some more of it. What's new we're seeing here is that you can set the auto start containers. That's the containers that can be automatically started for you when this whole thing starts up. So we're saying that, well, we're going to auto start the MySQL container because the Wi-Fi server depends on it. And then we have one configuration, and then the Wi-Fi MySQL latest configuration that extends that one again. So that's an extendable configuration, which essentially just links to the different databases. The complete example here would have then MySQL 6, MySQL 5, MySQL 4, and so on. Intended purpose here is to show that you could use Docker to improve the current testing situation on, for instance, a Jenkins by remapping the ports. There's always some kind of port conflict if there's multiple tests that are running against the same servers or services. Similarly, you can easily iterate over different database versions or implementation if your app needs to be able to run with different ones. That's some use cases. And if you think this, if anyone know how the Docker Compose format looks like, and this looks fairly similar. And why couldn't you use that instead? Well, you can. The thing is just that Arquillian Cube's format came before the Docker Compose format. So currently in the Alpha 7 of Cube, it's still our own format. That's the default version. But you can say by defining the definition format to compose, and you can use the Docker Compose format instead. Most likely that will change to be the default in some next version. Then there's kind of nothing Cube specific. It's just the normal Docker stuff. So I'm not confident that we have any better luck with this one, but let's try. So this is the same test. It's just running instead of running against the embedded database in Wildfly, it's going to run against the MySQL version of it. I'm getting anything here today. Oops. Well, it's doing something. Oh, that's not my day, obviously. Damn it. I can start to restart the thing, see if that helps. I swear it worked this morning, so. So let's see, Docker machine. There we go. Let's try to run it one more time. Come on, you bastard. Yes. There. So now we can see it starting up a Wildfly server and a MySQL server on the Docker machine. Eventually, when it's done doing that, come on. There we go. And it executes the test. And then, of course, shuts down the whole thing again. There's my Wildfly is gone and server's gone. Hey. And we have green bars. Awesome. Something works. Right, so the setup here, the point of the demo was to see how you could run on the different database types. So by just using some form of environment variable or system property, you can easily then swap which of these MySQL instances that you're going to start. So you will start a Wildfly and then something. We set up in a demo, it's either the latest or 5.5 MySQL. So that's that. And then there's the third one, which is the containerless Cube, which is essentially Cube's integration with Arquillian as a container, whatever that thing might be. So it's not an app server, it's not anything, it's just something that listens to some kind of IP, a port. So it could be a Node application, it could be a Netty, it could be a Spring Boot, it could be anything, essentially. It will be some form of black box testing. It doesn't have to be, because you can actually set it up to, never mind. It will kind of be a black box testing. So then, following the universe again, you just add a dependency on Arquillian cube containerless. And it's the same type of cube setup. So now we're configuring, instead of the previous one, we were using the chameleon container adapter. Now we're using the containerless. So we're saying that this containerless container should run against the image node. And node is built from this specific path that has the Docker file and so on. And it's going to be exposing some kind of port, which is 8580. In the next version, you don't even have to configure that. It will assume that, well, it will automatically expose the first port that is being exposed by a container, and if there's only one container, there won't be any, or it will select that. So these two subparts here can actually be removed in the next version. And then there's a Docker file template. There's some kind of environment or some kind of replacements that happens. So in this file, we're doing kind of standard stuff. We're inheriting from some file. We're making the directory. We're moving that into the working directory and adding a deployable file name, which is what you as a user provide to Cube through the deployment method as a tar file, for instance. So that could be anything. That could be whatever runs, essentially. And then we're just unpacking that into the app directory and then exposing the port and starting, in this case, Node. So the application that's being deployed inside of Node is a very simple REST endpoint type of thing that responds or returns some JSON. Nothing fancy at all, and very simple. And then the test part of it. So it's still the deployment that you're creating. We're not going to test in container at this point, so this is a testable false. We're just going to deploy it as is. We're creating a generic archive, which is a tar file, adding the package JSON and the app JavaScript file. And then that will be added to that Docker template. It will be built, and the end result of that container is a container with your defined app and so on in it. And of course, again, since we're controlling the container, we can also inject the URL to where this new container lives. And then we're using rest assured again to verify that the output is correct, essentially. I can try to run that as well. I think we're running a bit low on time here. Oops. Come on. So yeah, that's the same. So we do a run as JUnit. And then we should see there, it's starting up the node instance. That's node starting, and we're running, and green bar. Green bar. So that's the containerless. Okay. So we have. So what's coming next in Cube? As I was saying. Well, I wasn't saying that yet. Container objects. If people are familiar with the Selenium page objects, kind of encapsulating the logic of a web page into an object structure, Cube is coming with a similar that's called container objects, which essentially allows you to define the container and its dependencies, and how to configure it, and what kind of files to add, and all the Cube descriptors, or the the Docker compose and the Docker files, and mash them in together and their dependencies, and then inject back things like the host IP, and you can build around that to have a reusable container object. So if you have a service that has a few dependencies and some other developer want to run tests against that service, then you can just kind of give him this jar file that has this container object in it, and Cube will know how to start that server without having to distribute all the Docker configuration, essentially. You have a build on a jar. And then in the test case, you would then just inject it as a cube with a name and a type, and cube knows what the type means. And more integrations, of course. There's already in the latest alpha, there's OpenShift Kubernetes support, but it's built against a beta of OpenShift, so it's changed slightly now, so that needs to be updated. CoreOS or Mesos and Marathon are the other integrations that we're working on, and essentially will become the same as with the Docker daemon, that you can rely on their frameworks to do the deployment of the Docker files and images and containers, etc. So that's all I had. Sure.